Welcome to Learnmazing. Learning is amazing. This video will explain why we can directly put these two numbers next to x and y as coefficients. First, let's mark 2 points and draw a line. Traditionally, people prefer using the slope-intercept form, but this time we'll use the point-slope form, written as y minus y1 equal to m times x minus x1, where x1, y1 represents a point on the line. Alright, by definition, the slope is equal to rise over run. So, we draw a right triangle and mark the positions of rise and run. Now, let's simplify the point-slope form. First, we move rise to the left of the equation sign. It means that we multiply both sides by rise. Then, we use the distributive property to expand the equation. Next, I want to group x, y together and x1, y1 together. So, we subtract rise x from both sides and add run y from both sides. Finally, we get the following equation. And then we flip the signs. Returning to our problem, we replace the points A and B with the coordinates 2, 1, and 9, 4. We get that the rise is 3 and the run is 7. Now, we can directly put rise and run next to x and y. As for the right side of the equation, don't bother with the slow substitution or memorizing the form. We just need to substitute 1 point instead. Using the point 2, 1, we get a constant term as -1. Now, let's try another case where the slope is negative. Suppose the line passes through -2, 5, and 3, 1. According to the derived formula, the equation becomes rise x minus run y equal to plugging in numbers. Again, similar to the previous question, let's draw the right triangle and note the rise and run. If you're confident, you can skip the step. The run is 5, but in this case, the rise is -4 because it's downward. Alright, we can directly turn -4 and 5 into the coefficients of x and y and pick the point to calculate the constant term. Here, I choose 3, 1, and the result is -17. Since all three terms are negative, we flip the signs. Dealing with so many negative signs can be troublesome. So here's a tip. You can flip signs before substituting the point. In other words, you can change -4x minus 5y to 4x plus 5y before plugging in 3, 1, and the result will still be correct.